Okay, so we looked at the congruence theorem. It basically says if two figures are congruent, then all their corresponding parts are going to be congruent to each other, right? We looked at this. So basically, if two triangles are congruent, then they're going to be congruent in all aspects. So that includes all the side angles and all the side lengths and all the angle measures are going to be the same. If they are congruent, then they're basically going to be the same in all parts, right? We looked at this and it's pretty straightforward. What we added on to that is different theorems which we can use to prove triangles are congruent. So we can use the SAS theorem, which is the side angle side theorem, the AAS theorem, which is the angle side theorem, the ASA theorem, which is the angle side angle theorem, the SSS theorem, which is side theorem, and then the HL theorem, which is the hypotenuse length theorem. So we looked at all these, and basically depending on what our diagram looks like, sometimes we can use all of these theorems. Sometimes we can only use some of these theorems, but basically you can use these theorems to prove triangles are congruent. So what I'm basically going to review with you today is what are the criteria that we need to prove triangles congruent using these different theorems, okay? So let's look. First, the angle or side angle side theorem. So the side angle side theorem, what we need to prove is that two sides are congruent and then the included angle. Remember that the included angle was formed by two sides. So I have a side here and a side here. The angle that is formed by those two sides is going to be our included side. So in order to use the side angle side theorem, I want to prove that two sides are congruent, any two sides, and then the included angle. So for example, if I said that these two sides were congruent to these two sides, then in order to use the side angle side theorem, I also need to prove that that angle, the included angle, is also congruent to the other triangle. So if I can prove that two sides in the included angle are congruent to two sides in the included angle of another triangle, then I can prove that those two triangles are congruent. So that is the side angle side theorem. Also, just a quick reminder that we can differentiate the side angle side theorem because the A is in the center. If the A is in the center, we know we need that included angle. So that will tell us I need a side, the included angle, and then another side. So if the A is in the center, I need that included angle. Okay, questions about this? Okay. Now we're going to look at the angle side theorem. The angle side theorem basically says we need two angles and then a non-included side. I know I need a non-included side because that S is on the outside. It's not on the inside. If it was on the inside like this A, then I would know I need the included side. But because it's on the outside, I know I just need any side. It doesn't have to be my included side. Okay. So basically, I need two angles to be congruent. Two angles to be congruent, and then there any non-included side. So this one and this one. Okay. So non-included side and two angles. If I can prove those criteria to be true, then I can use the angle side theorem to prove these two triangles congruent. Okay. Questions about this one? Okay. Next, we are going to look at the angle side angle theorem. Here, your side is on the inside. So that should tell you you need that included side. You want to look for the included side because it's on the inside. Okay, so we need two angles and an included side. So again, any two angles can be congruent. And then the included side, so the side that they share, must also be congruent. So if I can prove that any two angles and the included side of those two angles are congruent to the other two angles in the included side, then I can prove those two triangles are congruent. Yes, questions? Okay. Next, the other one, this one's pretty straightforward. It basically says that all three sides must be congruent to all three sides. So if I can prove that all the sides are congruent to all the sides of the other triangle, then I can prove that those two triangles are congruent. So you can see how those three sides compare to each other. And so I can prove that all three sides are congruent. So I can use the side theorem to prove those two triangles are congruent. Okay. Lastly, we have the hypotenuse length theorem. In order to use the hypotenuse length theorem, you do need to have right angles or right triangles. So here I have one right angle, another right angle. So I have two right triangles. So I know I can use the hypotenuse length theorem. Then I want to prove that my hypotenuses are congruent. Remember, your hypotenuse is always opposite your right angle. So I want to prove that this side is congruent to this side. My hypotenuses, and then any leg. So I have two legs. I can show that any leg is congruent. So if I want to say this leg is congruent to this leg, then that works too. Okay. Just a reminder that these are your legs. You don't have to prove that both legs are congruent, just any leg that you want to. And this is your hypotenuse. Okay, questions about this one? And so those are all the different criteria that we need to meet in order to use each of these theorems. If we cannot meet one of those criteria, then we cannot use that theorem to prove those triangles congruent. Okay. Now, so we're going to look at this one. This is how can you justify that this side is congruent to this side? Okay, that's what it's asking. And so first you want to look at what criteria can you use or can you identify here? Well, you can identify you have two right angles. So that should take you to the hypotenuse leg. If you have two right angles, you may think, maybe I can use the hypotenuse leg there. I can prove that both of my hypotenuses are congruent to each other. And two of my legs are congruent to each other. So using the hypotenuse leg theorem, I can prove that these two triangles are congruent to each other. The triangle ABC, or ABF, sorry, is congruent to DEB. Now, how can I prove that these two sides are congruent to each other? Well, according to the corresponding parts theorem, I can prove that all those parts, now that I know that my two triangles are congruent, now I can prove that all those angle measures and all those parts are going to be congruent to each other, so all those side lengths. And so I can prove that these two triangles are congruent to each other, or these two side lengths. Okay, so first what I want to do is I want to identify what theorem can I use to prove these two triangles congruent. We can prove it using the hypotenuse leg because I know I have right triangles. I know I have hypotenuses. And I know I have legs which are congruent. That tells me I can use the hypotenuse leg theorem, and then according to the corresponding parts theorem, all my side lengths and angle measures are going to be the same. Okay, so basically what you should be able to do now is you should be able to determine what theorem can you use to prove these two triangles congruent. So here's another one. What congruence theorem can be used to prove that triangle BDA and BDC is congruent? Well, let's see what I'm given. I'm given that I have a side which is congruent. In my diagram, I'm given that this side is congruent in this diagram. And even though it's not stated, what I know is that this side is also congruent. What I notice here is that I have three sides which are congruent, so that should recall my side, side, side theorem. And so basically my side, side, side theorem can tell me these two triangles are congruent. All right, so what you're doing is you're trying to determine, given that diagram, what theorem can I use to prove those two triangles congruent? What is being told to me and what can I prove? So here's another one. Here, what I'm told is this angle is congruent to this angle. So I have two angles which are congruent. This angle is congruent to this angle. So other angles are congruent. And then what I can also get from this is that this side will be congruent. So I have a side which is congruent. Now what I want to identify is that my included side or my non-included side? That is my non-included side. And so I know I have two angles. So angle, angle, and my non-included side. So my angle, angle, side theorem is what I can use to prove these two triangles congruent. So based on your diagram, you want to see what information am I given? What can I conclude about the congruence between the sides and the angles? And based on that, I can determine which theorem I can use to prove those two triangles true. All right. Okay. Questions? So again, here is the overlay of all the different theorems that we've looked at and all the criteria you want to be able to meet. And so whenever you're answering questions, you want to make sure to have this available to you so you can know what criteria do I need to meet in order to use that theorem. Okay, questions? All right. If there's no questions, you guys may log off and I will see you guys on Monday. Bye, guys.